Hello viewers, in this lesson we will be discussing about moments of probability distributions. If you're new to this channel, make sure you subscribe and like and share the video to your colleagues that are also going to find it helpful. And if you're here to watch the previous lessons, kindly make sure you do justice to them. So without wasting much of our time, let's move into what we have in this lesson. Moments of probability distributions. So the moment, the art moment of a random variable x about its origin is given as, we're talking about moments. What should follow is about a particular point, but here we are looking for the moment about its origin. So the argument of a random variable x about its origin is given as mu prime r. So which is the expected value of x raised to power r. So anytime we are discussing about moments, what we are basically discussing about is also expected value. So if you don't understand the concept of expected value, you might be having problem with the aspect of moment. So if we are yet to understand the concept of expected value, kindly make sure you visit the previous lesson. So if you are asked to find the first moment, the art moment is what is mu prime r. So if you are asked to find the first moment, then it should definitely be what? Mu prime 1. That is mu 1 prime, which is going to be the expected value of x. Similarly, if you have to find the second moment of the random variable x, is going to be what? Mu 2 prime, which is going to be what? The expected value of x squared. If expected value of x is the first moment and the expected value of x squared is the second moment, definitely we can derive our standard deviation and variance from the first and second moment. Automatically our variance sigma squared, which is equals to the expected value of x squared minus the square of the expected value of x, which will definitely be what? Expected value of x squared is what? Mu 2 prime, which will definitely be what? Mu 2 prime minus the square of mu 1 prime. Square of mu 1 prime. So automatically the standard deviation which is sigma, which is the square root of what? Of variance, will definitely be the square root of what? Of mu 2 prime minus mu 1 prime all squared minus mu 1 prime all squared. So that is that about that. It is as simple as that concept. So without too much of our time, let's move into an example on this aspect. Let's move into an example on this aspect. So the first example says calculate the variance, that's sigma square, of the random variable x corresponding to the number of points rolled with a balanced die, corresponding to the number of points rolled with the balanced die. I will give f of x. Example 1, example 1, example 1, example 1. We will give f of x. That is, I said you should find the variance of random variable x corresponding to the number of points rolled with the balance die. So our f of x we're going to be what? We're going to be 1 over 6. You know, we are having 6 sample space in. We are having 6 elements in the sample space of the die. 1, 2, 3, 4, 5, 6. So f of x is going to be what? 1 over 6. F of x is going to be 1 over 6. For x equals to 1, 2 up to 6. So we have to find the variance. Solution. We have to find the variance. And to determine variance, I already given us the formula. Variance sigma squared, which is going to be mu2 prime, that is the second moment, minus the square of the first moment. That's mu1 prime squared. So recall that your mu1 prime, which is the first moment, is the expected value of what? Of x. Expected value of x. And recall the expected value of x is giving us, and as you can see, this is a what? This is a probability function and not a probability density function, because here we are having what? X is discrete and x is not what? X is not continuous. It is discrete. 1, 2, 3, 4, 5, 6. X is discrete. So automatically this is what? This is a probability function. You are not having your x in terms of inequality. So it is not continuous. It is what? It is discrete. And you recall the expected value for discrete random variable, that is for probability function, is given as what? Is given as the summation of x f of x. Summation of x f of x. So that will automatically give us, and in this situation, that will automatically give us what? X summation of x times f of x, which is 1 over 6. Times 1 over 6. Times 1 over 6. No, now let's pick our x one after the other. The first one is 1 times 1 over 6. 1 times 1 over 6 plus 1 times plus 2 times, because x the next x is what? Is 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. 6 times 1 over 6. So we're going to be summing those together with calculator. So if you do that very well, you should be having 21 over 6. 21 over 6. So that is the first moment, that is mu1 prime of the probability function. So the next is to look for our second moment, that is mu2 prime. Next is to look for our second moment, which is mu2 prime. So our second moment, mu2 prime, is giving us the expected value of x squared. Don't forget, expected value of x squared, because here we are having mu2, which is mu3, it will be the expected value of x cubed, which is mu4, it will be the expected value of what? Of x raised to power 4, and so on, because the rth moment, that is mu r, is the expected value of x raised to power what? Raised to power r. I already defined that in the beginning of the lesson. So mu 2 prime, which is the expected value of x squared, is given as, you know, this is the probability function. You will be having what? Summation s squared f of x. Summation s squared f of x. And that's going to automatically be summation s squared times what? 1 over 6. Summation s squared times 1 over 6. And that's automatically s squared, that will start with 1. That will be 1 squared times 1 over 6 plus 2 squared times 1 over 6 plus 3 squared times 1 over 6 plus 4 squared times 1 over 6 plus 5 squared times 1 over 6 plus 6 squared times 1 over 6. 6 squared times 1 over 6. So if we do that very well with our calculator, we should be having 91 over 6. 91 over 6. 91 over 6. Or you can initially break this down, that is the square. You can write out the corresponding value. 1 square will give you 1, 2 square will give you 4, 3 square will give you 9, 4 square will give you 16, 5 square will give you 25, and 6 square will give you 36. So you can firstly write that out, and before you add everything together with your calculator. So we have been able to get our first moment, been able to get our second moment. So we can now find our variance. Our variance, which is what? Sigma squared, and that's going to be what? That's going to be mu 2 prime minus the square of mu 1 prime minus the square of mu 1 prime. So that's automatically what are mu 2 prime? That's 91 over 6 minus the square of mu 1 prime. Our mu 1 prime is 21 over 6. Is 1 over 6. Square of 21 over 6. So if you do that very well, we should be adding 35 over 12. 35 over 12. And if you ask to find the standard deviation as well, just take the square root of 35 over 12, and that's the final answer to that. So moving on, we're moving to the next example, and the next example is going to be on probability density function. You know, this one is on probability function, so that one will be on probability density function. So this example says, find the standard deviation. The first one asks us to find the variance, but this one is asking us to find the standard deviation. That is, after getting your variance, you take the square root of that variance to get your standard deviation. So this one says, find the standard deviation sigma if f of x, which is the PDF, if f of x is equals to minus 4 over pi into 1 plus s squared for 0 less than x less than 1, and it is 0 elsewhere. 0 elsewhere. Solution. So this is a PDF. This is a PDF. So the first thing, let's get our first moment. Our first moment in 1 prime, which is the expected value of what? Of x. I know for PDF, the expected value of x is given as the integral from minus infinity to where? To infinity of what? Of x times f of x dx. Of x times f of x dx. And in this situation, we have what? We have minus infinity, integral of minus infinity to where? To 0. And that will be for 0. that is x times 0 dx, then plus, we ended at 0 here, we're starting at 0 at the other side. We have from 0 to where? To 1. Don't forget, that one is to 1 because we are having 0 less than x less than 1. 0 to 1 of what? Of x multiplied by everything here, which is what? Which is 4. Sorry, this is 4. Not minus. The question is 4, not minus 4. The question is 4, not minus 4. Take note. So x multiplied by 4 multiplied by 4 times divided by pi into 1 plus s squared into 1 plus s squared dx. 1 plus s squared dx. So now this will automatically become 0 because integral of 0 will give you 0. So let's focus on the other part. We have the integral from 0 to here to 1 of, and don't forget 4 is a constant. 4 is a constant. 4 and pi are constants. I can decide to bring out the constant. So here we have what? 4 over pi. I can bring out 4 over pi, then I'll be left with what? It's x over what? Over 1 plus s squared over 1 plus s squared dx over 1 plus s squared dx. So now I can now integrate. So let's integrate. Integrating 1 plus s squared. And you know, anytime you are integrating a rational value, that is why anytime you are integrating fractions, you check that if you differentiate the denominator, will it give you a denominator? So if you differentiate the denominator and give you the numerator, then you know the solution is going to be lean the denominator. So now let's check. If you differentiate the denominator, that is going to be giving us, the solution to that is going to be giving us 2x. But the numerator we are having was x. So since the solution to the differentiation of the denominator only differs to the numerator by a constant, so we can decide to divide the entire solution by that constant and still apply that same trick. It is going to work. So automatically, if you differentiate this, it's going to give you 2x. So we can decide to divide the whole problem with that 2, that constant. So automatically you have 4 over pi 1 over 2. I'm dividing by that 2. That's where it was 1 over 2. Leave that same trick. Leave the denominator, which is what? 1 plus s squared. But don't forget, you are integrating from where? From 0 to 1. So automatically 2 cancels 4. I'm left with 2. So I'm finally left with what? 2 over pi. 2 over pi. Leave 1 plus s squared. 2 over pi ln 1 plus s squared from what? From 0 to 1. 2 over pi ln 1 plus s squared from what? From 0 to 1. So I can introduce my boundary condition. But don't forget, 2 over pi is a constant. 2 over pi in big brackets ln 1 plus 1 squared minus ln 1 plus 0 squared. 1 plus 0 squared minus ln 1 plus 0 squared. So automatically, when I left it, automatically left it, you can decide to, if you do this very well, you can decide to use your calculator. If you do this, and if you do this very well, you should be having 0.4413. 4413. So just input it into your calculator and get your answer. This will give you 1 square will give you 1 plus 1, that's 2, and this will give you the 1, that's automatically in 2 minus the 1. So So the 2 minus the 1 multiplied by 2 over 5, let's press that in your calculator, then you're going to get the answer to that. So we have been able to get our first moment. So now let's get our second moment, which is what? Which is mu2 prime. Which is mu2 prime. So to get our second moment, mu2 prime, which is definitely going to be the expected value of what? Of s squared. The expected value of s squared. Expected value of s squared. Expected value of x squared. And that's definitely going to be what? The integral, because we are doing the PDF, integral from minus infinity to where? To infinity, from where? And we can of x squared times f of x dx. So here we have what? The integral from minus infinity to 0, that's for the lower value, of x squared multiplied by 0. You know, when we are moving from minus infinity to 0, the f of x is what? Is 0, plus the integral from 0 to where? To 1. We are moving from 0 to 1 for the second condition, and f of x at that condition is what? Square times 4 over what? Over pi. 4 over pi into 4 over pi into 1 plus s squared. 4 over pi into 1 plus s squared dx. Yes. This automatically becomes 0 as usual, because integral of 0, because everything here becomes 0, and integral of 0 will give you 0. So the other side will be left with the other side. But we're having a constant there, which is 4 over pi. So we can decide to bring out that constant. So we have 4 over pi integral 0 to 1 s squared over 1 plus s squared dx over 1 plus s squared dx. So how do we integrate this? And as you can see, if you want to apply the trick we applied to integrate the first one, it might not be working here, because if you differentiate the denominator, which is 1 plus s squared, you are not going to be having the numerator. It's going to be giving you what? 2x, and the numerator is what? S squared. So you need to do some manipulation or breakdown. So let's break. You want to try to break this fraction down. So how do you break it down? So you can write the fraction 4 over pi. You can write the fraction 0 to 1. You can write it as what? You can write it as 1 plus s squared minus 1. It is still the same numerator, because 1 can cancel out 1, and it will return back to this s squared over 1 plus s squared. We are not doing this just to make sure we break down the fraction into 2 parts. We want to break down the fraction into 2 parts, so that we'll be able to what? So that we'll be able to integrate. And if you encounter situations whereby you are unable to break it into 2 parts easily this way, you know, that is going to be resulting into what? Into partial fraction. So we are going to be using the approach of partial fraction to solve in that situation. But this is still a simple fraction. You can easily break it down using some sort of manipulation. So here we have what? So we have been able to break this down into 1 plus s squared minus 1, and if you add 1 and minus 1, it will come back to this. So we can write this as 4 over pi integral from 0 to 1, or what? Of, you know, we can decide to bring 1 plus s squared under 1 plus s squared and 1 plus s squared under minus 1. So it becomes what? It becomes 1 plus s squared over 1 plus s squared minus 1 over 1 plus s squared dx. And as you can see from here, this will become what? This will become 1. This will become 1. So let's write that. You are left with 4 over pi integral from 0 to 1, integral from 0 to 1, of what? Of 1 minus 1 over 1 plus s squared dx. 1 plus s squared dx. So we can easily integrate like this. So as you can see, if you can integrate 1 easily, and you can see that 1 over 1 plus s squared is a standard integral. Is a standard integral. Though if you try to apply that same trick, that is differentiate a denominator, it gives you the numerator that it really, that one it will not also work for this. But 1 over 1 plus s squared is a standard integral, which is what? Which is arctan x. Remember from your basic integration and differentiation knowledge, the integral of 1 over 1 plus s squared will give you what? Arctan x, and the derivative, that is the differentiation of arctan x, will give you what? 1 over 1 plus s squared. 1 over 1 plus s squared. So now let's decide to do that. We have what? 4 over pi multiplied by integration of 1. 1 is a constant. Integration of a constant, we are going to be introducing x. We are going to be introducing x. If you want to integrate 2, it is going to be giving you 2x. If you want to integrate 3, it is going to be giving you 3x. If you want to integrate c, it is going to be giving you what? Cx. If you want to integrate 1, it is going to be what? 1x, which is same thing as what? X. So here we have what? We have x minus, I already said the integration of this is what? Is arctan x minus arctan x minus arctan x from where? From 0 to what? To 1. From 0 to 1. So if we decide, we have 4 over pi there. We decide to introduce the boundary condition. If you are having 1 minus arctan 1 minus 0 minus arctan 0, 0 minus arctan 0. So you can easily do this with our calculator. So we do this very well. We should be having 0.2727. 0.2727. We are having 0.2727. So you can see everything here is going to be giving us everything here. We are going to be left with this, and arctan 1 is going to be giving 45, because the tan of 45 is what? Is 1. So arctan 1 is going to be giving 45. Arctan 1 is going to be giving 45, and 45 in terms of pi, you make sure you put it in terms of pi, because this is in pi, so you can decide to put it in terms of pi. So arctan 1, which is 45 in terms of pi, 90 is what? 90 is pi over 2, so 45 is going to be what? Pi over 4. So you'll be left with what? 1 minus pi over 4 times 4 over pi. So you can simplify it right from there. And mind you, if you are going to be using your calculator straight from here, your calculator should be in radian, because you are working with pi. You are doing it in terms of pi. Better still to be on the silver side, since you already know what the result is going to give you in terms of pi. So you can firstly write in terms of pi, then without using your calculator, then you simplify it with this after using your calculator. So we are going to get our sigma, we are going to get our first moment and second moment. So we cannot calculate our standard deviation. But before we calculate our standard deviation, we need to calculate our what? Our variance, which is sigma squared. So sigma squared, which is what? The second moment with 2 prime minus square of first moment minus square of 1 prime, which is equals to what? Our 2 prime give us 0.2727 minus 12 and 1 prime. Our 1 prime give us 0.4413 squared. And we simplify that, well, we should be having what? We should be having 0.0779. 0.0779. So if you take the square root of 0.0779, that should be giving us 0.2791. 0.2791. So that brings us to the end of this particular lesson. In the subsequent lesson, we will be moving to the next aspect of moment. The next aspect of moment, which is just an advancement of what? Of moment. So if you are new to this channel, kindly make sure you subscribe, you like, and you share the video with your other colleagues that are also going to find it helpful. Tutor Bosun is here. Thank you.